Okay, let me show you the difference between what arithmetic and geometric sequence. Alright, so let's say you're given an arithmetic sequence 5, 11, 17, 23, 29, 35, and then the geometric sequence is 2, 6, 18, 54, 162. Alright, so the first thing you do for arithmetic sequence, you find the common difference, and for geometric sequence, you find the common ratio. Then find the geometric arithmetic mean. Let's say arithmetic mean of a sub 1 and a sub 3. Then here, the geometric mean of a sub 1 and a sub 4. Then find the 1, 2, okay, 1, 2, 3, 4, 5, fifth term, and here find the fourth term, and then the sum of the 5 terms, and then here the sum of the 4 terms. Okay, can you do that? You can still remember the formulas? Okay. That one is correct. Okay. Yeah, maybe you don't need to write the decimal, or you cannot factor 108. That is 54, right? Okay, 108, 27. So maybe 27 times 4, so that is 2 square root of 27. 27. Maybe you can do this. 4 times 27, and 27 is 9 times 3, so you can write that as square root of 4 times 9 times 3, right? So, and 4 is a perfect square, so that is 2. Square root of 4 is 2, and square root of 9 is 3, and square root of 3, so this is 6 square root of 3. 36. The square of 6 is 36. 36 times 3 is 108. Okay. Then find the fifth term. Can you still remember the formula for arithmetic sequence? You want me to write it down? Okay, that'll be a sub n equals a sub 1 plus n minus 1 times d. That is for the arithmetic sequence. And then for the geometric, that is a sub n equals a sub 1 times r to the n minus 1. Right. a sub 1 plus, okay, that is 24 plus 5, right? Yeah, 24 plus 5. Okay. 4 minus 3 cubed. Okay, hold on. Michaela, it's not 6 cubed because this one is 3 to the 4 minus 1, so that is 2 times 3 cubed. You cannot multiply 2 and 3 here because they have different exponents. So you have to simplify 3 cubed first before multiplying it to 2. So you cannot do this, don't do this, the 6 cubed. So 3 cubed, what is 3 cubed? Yeah, 54, that's right. So the fourth term is 54. It's already here. So you've already proven. So that means you know how to do it. And then for the sum of the first 5 terms. So the sum again, what is that? S sub n, let me write down. S sub n for arithmetic sequence, that is a sub 1 plus a sub n over 2 times n. And then for geometric sequence, that is a sub 1 times 1 minus r to the n over 1 minus r. So we'll see. Five plus a sub n. A sub n is a sub 5. So what is a sub 5 here? A sub 1, a sub 2, 3, 4, and 5. So that is 29. 29 over 2. Then times n. Yes, n is 5. That's right. Okay. So 5 plus 29 over 2 times 5 . Okay, that's right, 85. Very good. 1 minus r to the n. Your r is 3 to the n. So n is 4, right? So 3 to the 4. Mhm. 3 to the power of 4 is 81. Okay. You have 1 minus 81 times 2, right? Don't forget the 1 here. So 1 minus 81, that is negative 80, right? Okay, so yeah, so negative 80 times 2, it's negative 160. Over negative okay. Yes, positive 80. Very good. Yeah. So you can prove it by, since you already given the sequence here, you can prove it by adding the 5 terms. So 5 plus 11 plus 17 plus 23 plus 29. If it's really 85, then here the first 4 terms, 2 plus 6 plus 18 plus 54, if it's equal to 80. All right. You understood everything? Shall we continue the rest on our next lessons? And you can send me whatever you have there, okay? Worksheets, because I have another student after you. Okay, what worksheets do you have there?